Welcome to the second part of our course. In this, we are going to learn about the data type and its size, operator in C++, control statements and looping statements. So let's begin. To understand what is data type and its size, let's have a look at the program. First, we will see what is char. Char, which is used to store a letter or a character. The size of char is 1 byte. Integer, which is used for whole number. This we have already seen in the first part of our course. The size of integer is 4 byte. Short integer, which takes less space than the integer, which is 2 byte and has shorter range. Long integer, which occupies more space than the integer, that is 8 byte and has more range. Float used to define the numeric values with floating decimal points. Size of float is 4 byte. And double, which has twice the precision than the float. Size of double is 8 bytes. Size of Size of is a compile time operator which is used to determine the size of a data type or a variable. Now let's run the program. Size of char 1 byte, integer 4 byte, short int 2, long int 8, float 4 and double is 8 byte. Now we will learn about the operators in C++. There are total 5 types of operators in C++. First we will see about the arithmetic operator. We already seen about the plus, minus, multiplication and division. Now let's see the modulus operator. Modulus operator outputs the remainder of integer division. What does it mean? Let's see that in the program. I will take the input from the user and see out a mod b. I will take the number as 10 and 2. The output will be 0. Why? Because 10 is completely divisible by 2. Now, instead if I take the number 13 and 2, the output will be 1 because there is the remainder 1. Next is plus plus, that is increment operator and is used to increase the value of integer by 1. Minus minus, decrement operator, decreases the integer value by 1. There are again two types of increment: pre-increment, post-increment, or pre-decrement and post-decrement. Pre-increment increments 1 and then returns. Post-increment, first it returns the variable, then it increments that by 1. To better understand, let's see a program. Here I have assigned integer x is equals to 10, then a variable a is equals to plus plus x. This is the pre-increment, and then I have cout pre-increment operation. A is equals to x is equals to, let's see its output. So a is equals to 11 and x is equals to 11. Now let's check what happens in post increment. For that I will write x plus plus a is equals to 10 and x is equals to 11. Got the difference? Now we will see about the decrement. Decrement minus minus x, 9, a is equals to, and x is equals to 9. And now post decrement. A is equals to 10 and x is equals to 9. So that's all in the arithmetic operators. Second is the relational operators. These operators will be more clear to you when we will be studying about the if-else control statements. In the relational operators, first is equals equals, which checks whether the value of the two operand is equal or not, and if the value is equal, then the condition becomes true. Second, not equals, which checks whether the value of the two operand are equal or not, and if the values are not equal, then the condition becomes true. Third, which is greater than, checks whether the value of the left operand is greater than the value of the right operand, and if yes, then the condition becomes true. Next is smaller than, which checks whether the value of the left operand is less than the value of the right operand. If yes, then the condition becomes true. Next is greater than equal to, which checks whether the value of the left operand is greater than or equal to the value of the right operand. If yes, then the condition becomes true. Next is smaller than equals to, which checks whether the value of the left operand is less than or equals to the value of the right operand, and if yes, then the condition becomes true. Third is the logical operators. We will see its example while studying the if-else control statement. In logical operators, first is the logical AND operator. If both the operands are non-zero, then the condition becomes true. So what does it mean? Let's see it by truth table. A, B, and output is Y. Expression is A into B. If A condition is true, B is true, then output is true. If A is true but B is false, then output is false. If A is false, B is true, output is false. And if both conditions are false, then output is false. Second is the logical OR operator. If any of the two operands is non-zero, then condition becomes true. Let's see the truth table. A, B, output Y, expression A plus B. If A is true, B is true, output is true. A true, B false, output true. A false, B true, output true. And if both conditions are false, then output is false. Third is the logical NOT operator. This is used to reverse the logical state of its operand. If condition is true, then logical NOT operator will make it false. Let's see the truth table. A, Y, and expression is A bar. If A is true, then output is false, and if A is false, then output is true. Fourth is the bitwise operators. In that, first is bitwise AND, which takes the two numbers as operand and does the logical AND operation on every bit of a two number. The result of the AND is 1 only if both bits are 1. For example, take two decimal numbers 5 and 9. Its binary format it's 0 1 0 1. In binary we represent 9 as 1 0 0 1. Now perform the logical AND operation on its bit. 1 1, both the condition is true, therefore output is 1. 0 0, both condition false, output false. 1 0, true false, that's false, and 0 1, output 0. So if we 5 and 9, its output will be 1. Next is the bitwise OR. It takes the two numbers as operands and does the OR operation on every bit of the two numbers. The result of the OR is 1 if any of the two bits is 1. Let's take an example. If my number is 5 and 9, we represent 5 in binary as 0101. 9 is represented as 1001. Now perform the logical OR operation on its bit. 111000, 101 and 011. In decimal, this represents 13. So 5 or 9 will give us the output 13. Next is the bitwise XOR. It takes two numbers as operands and does the logical XOR operation on every bit of the two numbers. The result of XOR is 1 if the two bits are different. Let's see the truth table of a XOR first. A, B, and Y is the output. 0, 0. This is going to give the output 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. If both the conditions are same, like both the conditions are false, then output is false. Here both conditions are true, then the output is false. And if a condition is false, second is true, then the output is true. Now let's see an example on bitwise XOR. Let's take the number as 5 and 9. So 5 is represented as 0, 1, 0, 1. 9 is represented as 1, 0, 0, 1. So 1 XOR 1, 0, 0 XOR 0, 0, 1, 0, 1, 1, 0, 1. Its decimal is 12. Therefore 5 XOR 9 equals 12. Next is the bitwise NOT, which takes one number and inverts all its bits. Let's see an example. Number 5 represented as 0, 1, 0, 1. Here we also have to take these additional zeros. In previous operations, we did not consider these bits as that was not affecting our result, but here that's going to affect. Now let's perform the operation. That's going to invert all the bits. That is 1 becomes 0, 0 becomes 1, 0, 1, 1, 1. In decimal, this number is 250. So bitwise not, that is bitwise not 5, is going to return us 250. Next is the bitwise left shift. Bitwise left shift takes two numbers, left shifts the bits of the first operand, and then the second operand decides the number of the places to shift in the first operand. Let's take an example. The number 9 will be represented in binary. 1, 0, 0, 1, and 0. This 1 will move towards the left by 1 bit. This 0 again moves towards the left side by 1 bit, and it follows. At last, this gets lost, and the first digit is replaced by 0. So our answer becomes 0, 1, 0, 0, 1, 0, 0, 0. In decimal, this equals number 18. So our answer is 18. And at the last, we have the right shift. It also takes the two numbers and right shift the bits of the first operand, and same, The second operand decides the number of the places to shift. Again, I will take the same example, 9, right shift 1. We have to represent 9 in the binary format. One, 0, 0, 1 and 0. This is called as MSB, that is most significant bit, and this is called as LSB, that is least significant bit. The most significant bit moves towards the right by 1 bit. This 0 follows the same, and at the last this LSB bit gets lost and 0 is replaced in the MSB bit. So our output is 1, 0 and zeros. In decimal, this equals number 4. So our answer is 4. Now we will learn about the control statements, and in that first is a switch case. Do you remember the program that we tried in the first part of our course to add, subtract, multiply and divide the number? But in that we didn't give the choice to the user to perform a particular operation, and that's what we are going to do using the switch case. Switch case statement is used for checking the operator entered by the user. Now let's see the program. I will type character choice and integer a comma b. Then I will prompt the user cout enter plus or minus or multiply or divide. I will accept its choice. Then I will say the user to enter two numbers, and I'm accepting that number first. Then type switch choice in curly braces, type case in single quotes plus, then semicolon, and add the numbers here. After that type break. Break is used to terminate the loop. Then similarly I will copy paste this. Instead of typing, this will be minus, multiply and divide. We'll change it and divide. After that I will write the default case to be executed. For that, default cout invalid input. If the user enters any character rather than the plus, minus, multiply or division, then the default case gets executed. And then break to terminate the loop. After that return 0. Let's see the output. Enter plus, minus, multiply or divide. I will take the plus into two numbers 5, 9. 5 plus 9 is 14. Let's try again with the other operators. Minus 5, 9 minus 4. Multiplication 2, 6, 12. Division 6, 3, 2. Next in the control statement we will study about the if else. For that we will write a program which compares the two number and returns whether those are equal or one number is greater than other or one number is smaller than other. So I will write integer a comma b, prompt the user to enter those numbers, accept the value. I will print the value cout a equals and b equals b. Now the if else part. If a double equals b, this operator we already discussed. Cout equal else if a greater than b, cout a is greater, else cout b is greater. So if branch is executed only if the condition is true. Means if the two numbers are equal, let's say 2 and 2, then this branch is going to be executed. We will get the output equal and the program will stop. Now let's take another example in which a is 6, b is 3, a is greater than the b. So if branch will be false now, but else if will be true and we will get the output a is greater and the program will stop. Now if none of the condition is true, then else part gets executed and we will get the output that b is greater. Now let's run the program. Enter the two numbers. First I will execute the first, that is a equals b, 2 2 equals to b equals to, and the output is equal. Let's write endl here to be more clear. Let's run the program again. A is 6 and b is 3. A6, B3 and A is greater. 3, 9. A3, B9, B is greater. Now we will see a program which uses the logical OR operator. This program finds whether a enter character is a vowel or a consonant. For that, type C character CH. Prompt the user to enter a character. Accept the character. Then if CH double equals in single quotes or double quotes A or ch double equals, if you use the single quotes, make sure you use the single quotes only again, or if you use the double quotes then use double quotes only. I, O, and U. Then cout vowel, else cout consonant. Return 0. Let's run the program. Enter a character A and it's a vowel. Now let's enter P, consonant. If we want the small cap letter also, we can do it. Just copy this and replace the capital letters with the small. So it will work for all the inputs. It should be the small ch because C++ is case sensitive. Enter a character, small o, and it returns as vowel. Before we proceed with the looping statement, there is a small assignment for you. Make sure you stop the video and try it yourself. The program which we done using the switch case, you have to do that using the if else. Okay, let's check the solution. I will clear this previous output first. If ch double equals in single quotes plus, so need to accept the numbers integer a comma b, cout, enter two numbers, say in a b, and I will give you a hint to the user that enter plus, minus, or multiply or divide. Then cout a plus b, else if ch double equals minus, cout a minus b. If character is multiplication, then cout multiplication, and for last else cout a divides b. Let's run the program. Enter a character, I enter plus, enter the two numbers 8 and 2, 10. Let's try with the division. Enter the two numbers 6, 3, 2. So yes, we can also do the same program using the switch case as well as using the if else. Now we will learn about the looping statements. Now we will study about the looping statement, and in the looping statement we will study about the while loop. I will show you the syntax of the while loop first. We write while parenthesis condition curly braces and then the code of the block to be executed. This is the syntax. Let's see a program to print whether how many numbers are even and odd within a particular range. For that I will type integer n comma I equals 1. I will prompt the user to enter the range. Cin n, then while I smaller than n, I smaller than equal to n, curly braces, in that if I mod 2 double equals 0, cout even number and the else part. And I have to increase the counter. For that I write I equals I plus 1. Semicolon was missing. Let's run the program. Enter the range 10. So odd number 1, even 2. Um, because of this 0, it printed 0. Let's run the program again. Enter the range 10, odd number 1, then even 2, odd 3, even 4, odd 5, even 6, and so on. Now let's see how our program is working. First of all, I equals to 1. This is the initialization of the loop. Then our condition is I smaller than equals to n, and n is the range. I enter range as a 10, and therefore the loop is executed 10 times. At last, the value of the I, which is the counter, is incremented by 1. So first condition is that is 1 smaller than 10, yes, and this inner loop is executed. Then value of I is incremented by 1, that is 2. 2 is smaller than 10, and then again this is executed. This continues till the value of I becomes 11. At last the condition becomes false and the program stops. Next, in the looping statement we will study about the for loop. I will show you the syntax of the for loop first. Syntax is for initialization, then condition, and then counter. Initialization initializes the variable and is executed only once. Condition: if true, then the loop is executed, and the counter, which increments or decrements the value of the initialized variables and loop. Let's see an example. I will write a program to print the string n number of times. We will take the value of n from the user. For that, I will type integer n, cout, enter n, then for integer I is equals to 0. This is my initialization. My condition is that I should be smaller than equals to n, so that n times the loop will be executed, semicolon. Then I want to increment the counter here, so I plus plus. I will write the string for loop. Let's try to run the program. Enter n. Let's say we will repeat the for loop string 5 times. So it's going to repeat the for loop word. More clear, let's write here endl. Let's say I want to repeat the string now 10 times. So it will repeat 10 times. Now what we will do is that we will try a program to print a pattern using the for loop. This is the pattern which we have to print. Make sure you try yourself first, then I will show you the solution. So to print this pattern, I will first clear this previous program. Declare the two variables I, j. Then use for loop. Initialize from 5. Condition should be that I must be greater than equal to 1. And our counter should decrement. We need one more for loop. For j equals to 1, it should be its initialization. Condition is that it should be smaller than equals to I, and its counter should increase. In the second for loop, we will print star, and in the first we will use slash n to get the new line. Let's run the program, and yes, our output is correct. The last concept in the looping statement and the part 2 is do while loop. I will show you the syntax first. Syntax is do, curly braces, code to be executed, while, condition. That's the syntax. So let's see what's the difference between the while and the do while loop. In do while loop, loop is executed at least once, then the condition is checked. But in the while loop, first condition is checked and then only the loop is executed. To understand this more clear, let's see a program. I will write a program which will print numbers from 1 to 5. Integer I is equals to 1, that's the initialization of the loop. Do cout I handle, and I will increment the counter here plus plus I. Then the condition part, that is while. Condition is that I should be smaller than equals to 5. Let's run the program. Yes, answer is 1 2 3 4 5. Here 1 is printed directly, then the counter is increased, then the condition is checked whether 2 is smaller than equals to 5, which is true, and then 2 is printed. And same what happens till the integer 5. But in the while loop, first the condition is checked and then the loop gets executed. That was the difference between the while loop and the do while loop. So now we have completed with all the basics of C++. I'm having an assignment for you. You have to write a program to print a Fibonacci series. Second is you have to write a program to find prime numbers in a range 1 to n and take the value of n from the user. Third is you have to write a program to find a factorial of a number. We will be discussing the solutions of these programs in the next part before beginning with the actual concepts of the next part, that are function, pointer, arrays, and lots more. I hope you are enjoying this course. So let's see you in the next part.